Please do try to participate in class. Don't be shy. Just unmute yourself and ask a question if something isn't making sense. We're gonna have lab sessions and stuff too that I'll talk about later. So we'll break out into groups, and then I'll jump around between the different groups and things. That works pretty well. It's not as well. It doesn't work as well as it does if we're all in class together, but it works okay. So anyway, thank you all for taking the time to tell me a little bit about you. Okay, on with the rest of the class. So a few class policies. The first is be kind, right? And this sounds maybe a little overly pedantic, but it's really important to me that this is not just something that we're all doing, it's literally a policy. Be kind to each other and be kind to yourself, okay? This stuff that we're learning is really hard, as most of you already know. And so you just really have to have patience with yourself in addition to others, right? Not everybody learns at the same speed. You're going to be working with people that are way ahead of you sometimes and way behind you sometimes. And all of that can be frustrating. So just try to be kind and try to be understanding with yourself and with others. So if you find that you're the one that's way behind somebody else, try to not let that introduce anxiety, right? Instead, just say, they're a little bit further along on their path. I'm going to get there, right? Whenever possible, please help others, okay? So that's a big part of group work. It's also just a big part of this entire sequence of courses, right? I really believe that we all learn best when we're all working together. So if you see an opportunity to help somebody else, please do so. And that includes me. I have a specific example where I'll be asking for help here in just a minute. But really, anytime you see anywhere that you feel like you could help somebody, please do that, okay? I really do view this as like an incredibly important part of this class, not just in terms of decency, but also in equity and making sure everybody feels welcome and that everybody feels, like they belong here. I've, done a fair amount of research on achievement gaps and things like that, as I mentioned. And if you look at specifically like computer science type classes, you have a lot of dropout early because certain groups of people are not feeling like they belong. And so this slide is really in large part to say that we're not going to let that be the case. Okay, so try to be kind with each other, with yourself. And if you start to feel like you're being sort of pushed out, please be open with communication and talk to me, and we'll figure out what's going on and how we can address that. All right. Okay, a bit more specific. Normally, I would have information here about welcoming kids into class. Many people are parents. I am a parent, as I mentioned, but because we're virtual, that's both easier and harder, right? So it's easier probably because you're probably home with your kids if you have kids. It's also harder because you're home with your kids and you're trying to do a PhD program. So if you happen to have kids and you need to have them with you while we're doing Zoom, that's totally fine. If you need to leave to be with them for whatever reason, that's totally fine too, okay? No problems at all with any of that. And so going along those lines, you can jump in and out of class, not a problem. If you think that you're going to be doing that, like maybe you have a typical situation where your kid is on Zoom themselves going to school, but then they're like today, not actually in school. So you feel like there's a good chance you're gonna have to be jumping in and out a little more, maybe send me an email, okay? But if something comes up and it's not, and you can't really tell me beforehand, that's fine, it's not a problem. Okay, so that's what that is about. Okay, last sort of intro thing before we really get to the syllabus. I'm here for you. That's really my job. That's my role, is to be here for you. Okay, so we're not going to have specific office hours, but you can email me at any point if you want me to meet with you individually or in a small group or whatever. Okay. Like all of the courses in this sequence, this course can for sure be quite difficult. So please don't try to do it alone. All right. If you're working on a problem and you've been working at it for like a couple of hours and you've made very little progress, don't just keep hammering away. All right. I think that is probably the biggest challenge that people have, is they don't want to, like, I don't know if it feels like they're admitting defeat or what, but people will work for 10 hours sometimes on one problem. It's like, stop, email me and then we can talk about it. I can help you through that part and then you can move on with the rest of the lab or whatever it is. Okay. So please, please, please contact me if you need help. Don't get stuck for unreasonable amounts of time. Okay. And ultimately you have to decide what's unreasonable, but please do try to reach out to me, not try. If you reach out, I will respond and then we can meet and I can help you through. Okay. All right, any questions on any of that before we get to the syllabus? All right, so syllabus. First of all, we will have a class website. I sent out an announcement about this, and we will have a course repo, okay? Actually, the course website builds from the repo. This is what it looks like. This is actually a little preview of the whole thing, but I'm gonna just click here and actually go to the website so we can walk through this a little bit, all right? So this is just sort of an overview of what the course is. And then we have the schedule here. So these are the different books that we have. And then we also have this book up here, which is one I'm currently writing with these people who both went through the sequence as well. They're both really amazing people. But then down below, we have all of the course content. Okay, so for each of these, you'll see a little icon like this that will pop up when the slides are available. What I'm going to try to do, and I can't promise this, but what I'm hoping to do is add all the slides in from last time I taught this class, and then they'll all just be there. And then you'll know if they've been updated because I've changed the theme that I'm using for the slides. Okay. So that way you'll have the content beforehand, basically, if you want to look at it before, but the most up-to-date stuff will be coming. All right. If there's anything assigned, you'll see that here. Today, the final project is assigned, which we'll get to in just a minute. And then if there's anything due, you'll see that there. You'll also have the readings linked there. And then after we're done here, so right now I am recording all of this. And then I'm going to post it, and then this will be a link to the thing. Right now, it's just a GIF because I just needed something to link to, but that's what that will be. Okay. In terms of these books, these are all great books. The ones that we'll use the most are these two, this one and specifically this one. This is a really, really good book. And then there's some other readings that I'll have too. So in this case, this other reading is actually a chapter from this book. So it's the most recent one that I wrote, which is on collaborating with Git and GitHub. Okay. And that's going to be the next lecture that we talk about. Okay. So that's that. And then on the assignments page, you'll see the labs, the homework, and the final project, the components of the final project. The syllabus, this is just an online syllabus. This is everything that we're going to talk about. There's this tags, which will basically probably just always be assignments and labs. But there's two ways that this is linked. The first lab is already posted, so you can click here and get to the lab, or you can go to tags and say lab, and then it'll say, here's the one lab. You click on that, and there it is. Okay. And then the last part is the class repo, which is here. Okay. So what I would like for you all to do is ideally now, if you haven't already, or shortly after class, please clone this repo. All right. And then I'm going to be pushing changes up there every week that will then publish to the website. But you can just poll each time for new changes each week before class, okay? And sometimes there'll be edits that are made like literally minutes before class, like today there were a few. So you can poll whenever throughout the week, but you should probably always poll again like right before class just to make sure you're up to date, okay? So we'll talk more about that as well, okay? So nearly everything that we do in this class will be distributed through the repo, all right? So you'll see the labs are posted there, the homeworks, everything, okay? So there's really, the only thing we're gonna be using Canvas for is for, you know, to grade things, enter scores for assignments. Other than that, we're really not going to be using Canvas. Okay, so that's why I say it's important that you clone the repo, and then going to the website is going to be important too, because that's where everything is going to actually be. Okay, just a couple notes on R Markdown. These slides are produced with R Markdown. The other slides I'll post too are like a UO theme. Those are produced with R Markdown as well. I really encourage you to try out slides with R Markdown, but I'm not ever really going to lecture on it. Okay, so for your final project, you're going to have to present. You'll have like a 5-10 minute presentation on your final project, and so I'd really encourage you to use SureEngine, which is the package that I'm using to create slides. If that's, you know, if you're feeling overwhelmed with everything already and that's too much, then don't worry about it. It's not a big deal. You can use PowerPoint or whatever. But there's a lot of reasons why I think these slides are nice. I think they look nice. They're HTML, so they're easy to publish online. But they also are nice for reproducibility purposes, because when I'm creating these slides, for example, not in this case because I don't have any code really in these slides, but you know, I almost always have code that I'm trying to show, and the slides will actually run that code and then show the output from that code. So if the output is looking correct on the screen, then I know that my code is right and I don't have errors in it, right? Whereas if I'm using PowerPoint or something like that and I'm copying and pasting code, I might update something and forget to copy and paste the code, and so then things might get out of sync or whatever, right? The website that I just showed you was also produced with R Markdown, sort of. It was produced using Blogdown, which uses Hugo, and then some custom CSS and some custom Hugo shortcodes and things. But basically, that's just to say that R Markdown is really powerful. And I think probably many of you know that, but these are maybe a couple of examples that you might not have seen in terms of how R Markdown can be used. And I point this out because this course is not just about data visualization, but also mediums for communication. So we're going to talk about dashboards and websites, both, later. And we'll talk about probably simpler versions than this, but this than the website that I showed you for the class website. But you will have the repo for the website too, so you can see all of that if you want. Okay. All right. Quickly, I wanted to go through sort of my assumptions about you and what your skills are coming into this class. And if any of these assumptions are incorrect, that's okay, but you will probably know that that's an area that you need to probably dive into a little bit more as we go along than maybe other students. And part of the reason I'm showing these slides is because we have a fair number of students, not a ton, but quite a few, who didn't take the first class, but instead, you know, I admitted because you took the courses in the psych department or whatever, right? And so those courses in the psych department will cover most of what's in the first course, but not everything. And so there might be a few things that are missing, all right? So I assume you understand the R package ecosystem, how to find, install, load, and learn about them, and that you can read flat files into R. So I don't care what you use. You can use readr, you can use whatever, but you should be using the here package. I think that's an amazing package, actually. It's really, really good. If you're not convinced you should be using that, I would suggest you read this blog post by Jenny Bryan. You should also probably be using RStudio projects, okay? If you use both of those things together, then your project will be reproducible across anyone's machine, and you won't be beholden to the specifics of one person's machine. A good way to do this that I used to do before the here package existed is just using relative paths. So, starting at a specific location and then using relative paths from there. But here makes it even easier and more robust because file path issues differ across operating systems. I assume you can perform basic data wrangling and transformations in R using the tidyverse. So this course is mostly focused around ggplot, but the first course is mostly focused around tidyverse. And we're pretty tidyverse centric in all of these courses, right? So leverage appropriate functions for introductory data science tasks and clean up the script, whatever needs to be done to clean it up, using scripts and reproducible workflows. And that reproducible part is really important to me, okay? Ideally, well, not ideally, for the final project, you will have to have your project hosted on GitHub, and I should be able to clone it and reproduce it all without any problem, okay? I assume you can use version control with R via Git and GitHub. If you don't have any experience there, then you'll definitely want to do the reading closely and probably go through some of that a little bit more in depth. And that you can use R Markdown to create reproducible and dynamic reports. Okay, so that's my assumptions about you. The learning objectives for this class are a couple, okay? This is the second course in the sequence of courses, so it is primarily focused on data visualization and communication, but it's not entirely focused on those things, okay? There are a couple of lectures that sort of are separate from that, and that's mostly because it was difficult to figure out how to include all of that content in the first course. Probably the biggest topic like that is joins. Okay, so we're going to have an entire lecture on joins, which aren't covered in the first course at all, but they're a super important topic. And so I felt like we had to include them, but I just couldn't include them in the first course because there's so much content there already. All right, so we're going to have a lecture on joins. We're also, this is the first time I've done this, but we're going to have an entire week on Git and GitHub. And the reason for that, well, an entire lecture, I should say, which is going to be Wednesday. Okay, and the reason for that is because I have found that even all the way to the fourth course, many people are still struggling with Git and GitHub. And I totally get it. I struggle with it still sometimes, right? But my goal is to be really explicit about it so that you all will have a better foundational knowledge moving forward than maybe others would have who took these courses before, okay? So transform data in a variety of ways. Understand and fluently apply different types of data joins, as I mentioned. Some best practices in data visualization. We're not going to get to everything, of course, but we'll hit on a lot of the sort of main things. And then customize ggplot2 graphics by doing things like reordering factors, creating themes, etc. Just basically, if you have a base plot, that's great, but then how do you transform it to make it go from like, here's a great exploratory plot to here's a plot that I'm going to use to publish in, maybe I would produce it this way if I'm publishing it in like a, in some format that's meant for like a general public audience, and I might produce it slightly differently if I'm using it, if I'm trying to publish it just for a scientific audience. And then we're also going to create this is your final project, right? Create an online data visualization portfolio. You will use probably either Distill or Flex dashboards to demonstrate your key learning. Okay, so very quickly, I have to go very quickly because we're starting to run out of time. I have a couple examples here. I'll just show one of each, and then you can come back and look at these if you'd like. This is an example of a dashboard. This is from Alexis. So this is what she did during the course. This is what she started out at. This is a second example, and then this is her final project, or her final data viz for this particular one. For her second one, this is where she started, then she moved here, then she moved there. Third one, fourth one, and a fifth one. Okay, she went a little overboard. She had 5. You only need 3. That's why she was saying bonus. But anyway, and then this is a blog post. And here's an example, right? So here's some stuff, and then here's some code, and then there's some more code, and now I'm going to talk about it more, and there's the code, and there's an initial plot. Okay, and this is like part of what your final project is about. And there's now a second one, right? And then a fancy, cool, right? And then I think she even has right down here. Yeah. Notice those are moving. So that's pretty neat too. These are called HOPs, hypothetical outcomes plots. All right, so those are 2 examples. You can look at the other ones if you want, but those are 2 examples of the type of thing that you'll be producing for your final project. Okay. I'm also going to try to provide weekly learning objectives. So this, or it shouldn't really say weekly. It should more say by lecture. It used to be well, I tried to structure it initially so that each week had a theme, and we would have lectures on Monday and labs on Wednesday. But again, in an effort to sort of jam in more content, I got rid of a couple of labs, and so then we just have 2 lectures in the same week sometimes. And so it's the whole week might not be coherent in terms of its theme, but each lecture should have some learning objectives. Okay, so for this week, it's basically just understand the requirements of the course, understand the requirements for the final project, and be ready to go with Git and GitHub for Wednesday. Okay. All right, required textbooks. These are both free. They're both excellent. Those are the primary texts we'll be using for the course. Other books that are also free. This one by Jenny Bryan is on Git and GitHub, specifically for our users. And then R for Data Science, that's what you used in the first course, and that's great sort of foundational text. We'll be using a chapter from that for joins, for example. All right, another resource. This is the book that I'm currently working on. I'm go here. So this is what it looks like as a full website. Pull this out a little bit. Well, whatever. This isn't up there. That's what it is. Okay, so it looks like it has a ton of chapters. Most of these are empty. Okay, so this is like an outline of the book essentially, and what we're hoping it will be is just like course notes for the entire sequence. And so along those lines, one of the chapters that actually is done or has a draft completed anyway is this chapter, chapter 8, collaborating with Git and GitHub. Okay, so I would ideally really like you to read this before Wednesday if you have the chance. And this is where I would love your help. Okay, so this talks about forking repos and making pull requests and branching and all sorts of other stuff that we'll talk about Wednesday. But if you are reading this and you see errors, either, or maybe something is just really confusing or whatever, maybe typos, anything that you see, I would love if you would contribute to the book, right? So you could fork the repo where the book is housed, which you can see right up here, that little GitHub icon. So here's the repo, right? You could fork this, and then you'd have your own local or remote, but you would have your own copy, which you could clone, make edits, push that to your version, and then submit a pull request to say, here's some edits to the chapter, and that would be awesome, right? That would be very helpful for me. So certainly that's not required, But if you feel like doing that, that'd be great. And then I'll, we'll have a little acknowledgments thing, and your name would be listed in there as a contributor to the book. Okay. So there may be other readings that I suggest from this book, but there's the only one that I'm putting as required, and all of it is just like, please do. But if you don't have time, then you don't have time. So, but is that collaborating with GitHub one? Okay. All right. There is also an extra credit opportunity for 10 points, and it's basically just to do a deep dive into a topic that's not covered by the course. So there's so much out there around, data visualization, and a lot of it we won't talk about. Okay, we will have one lecture on geographic data, but there's just so much in that area on its own. You could easily, and there are courses that are just about geographic data viz sort of stuff. So if that's something you're interested in, that would be great. I will get the old lecture posted soon-ish. So maybe take a look at that before you decide if that's what you want to do, so you can cover things that aren't covered in the lecture. But that might be a great thing to do. Network data, text data, DAGs, which I'll show examples of here in just a second. Flow data, so like, well, I'll show another example of that here in a second too. Relational data, so again, this is sort of outside the topic of data viz, but it relates to joins and things like that. So if you want to do something related to SQL or whatever. Interactive plots, we will, in the next course, we'll talk about Shiny and creating graphics that change based on inputs. But we won't really have any of that in this course. So if that's something that you're interested in, that would be great. And animated plots, so not interactive, but like what we just saw where, the lines are moving. That would be like probably GG Animate, right? So a few examples real quick. This is an example of a map created by this guy, Timo Grossenbacher, that I think is incredible. I think it's beautiful, and it really shows the differences by area as well. And this is a blog post where he walks through how he created this map exactly. Okay, so if that's something that you're interested in, that'd be a great way to go, right? This is more of a network diagram, right? And this is for this guy. That's not very clear, but I should probably change the text color there. But anyway, these are different soccer clubs, I think, and yeah, World Cup 2018. So I think that's really nice as well. And then this is a DAG. So this shows sort of relationships between things and, basically ways of getting at causal inference. This is from the ggdag package from Malcolm Barrett. So I think this just links to the package itself. Yeah, so here's an introduction to it. Okay, that'd be great. And then here's like a flow diagram, right? This is an astounding figure, I think. Black and white boys raised in wealthy families. So they all grew up rich, and then you can see what they ended up as adults, right? So I think this is an example of a really, really powerful visualization using flow data. So something like that would be great as well. And then this is an animated one. This one's crazy, I think. It's showing basketball players, right? But part of what is neat about this is, and this is just kind of true of lots of, R and data science stuff, is this links to the code to produce this figure. Okay. So this is an example of an animated plot. It's a really complicated example, but if that's something that you're interested in, we would love that too. Okay. So again, I don't think I actually said this. If you're interested in doing an extra credit opportunity like this, you would just pick an area then you'd check in with me. I would say, yep, that looks great. And then at the start of one of the classes, you would give a 10-minute presentation on that topic. Okay, so you would go and do some research on your own, create a couple of slides about that topic, and then basically just give us a short little presentation on it. Okay, totally not required, but if you're interested, you can get up to 10 points extra credit for that. Okay, labs. I significantly reduced the labs. The first time I taught this course, I think we had 6 labs, and then we had maybe 4 labs the second time, and now we have only 3. And part of that is because I added a few more topics. It's also partly because we're in a pandemic, and so I'm trying to reduce the amount of stuff that you have to do, okay? While still hopefully making it so you all really learn the content too, right? So we're gonna have 3 labs. The first is going to be about distributions primarily, visualizing amounts, and then it'll be a GitHub collaboration. And that lab is actually already posted. You can look at it. You probably can't do it until we get to the class because it's a group project, right? But similarly to pre-posting the lectures, I'm going to try to update the labs as quickly as I can and get those posted as well, so you can work on those at your own rate too, if you feel like you're ready for the second lab, and even though we haven't gotten to that content because you've reviewed the slides that are there or whatever, and you want to just go ahead and get a jump start because you have some time, then you can do that. Okay. The second one will be on visual perception and reproducing plots. So I'll just show you a plot, and then you'll have to write the code to reproduce that plot. And then the last one will be on color. Okay. Homework, we're going to have 2 homework assignments. They're 20 points each. They are basically the same as the labs. The main difference is they might be a little bit longer, and the primary difference is they are actually scored on a correct-incorrect basis. Okay, and there's no in-class time devoted to homeworks, right? Whereas labs, we'll spend the whole day on a lab. Okay, so there'll be 3 class sessions where we'll spend the entire day on that lab. Okay. It's totally okay to work collaboratively on homeworks and on any of the labs, not just the first one. And I actually actively encourage you to do so. Please do work together. The only thing with that is if you are working together with somebody, then it has to be through a GitHub repo. Okay, so you have to have a shared GitHub repo, and you have to both have commits to it. Okay, so if you're working in a pair, you should both have commits in that repo. If you're working in a group of 3 or 4, then you should all have commits there. Okay, because when I go to grade the labs, I'll give you all the same feedback in the group, and then I'll probably give you all the same score, but I will just go and check the commit history quickly and make sure that everybody has been contributing. I know that commit histories are not a perfect representation of contributions to projects, but that's part of why I'm trying to be very explicit about this. You need to have contributions to the repo, okay? So we've had issues in the past where somebody didn't have a single commit in the repo, but they were a really important part of the whole project. They just didn't make the commits. So don't let that happen, okay? Let's have everybody making commits, because that's really part of what this is all about too, is learning how to work collaboratively through GitHub. Okay, homework 1 is going to be on creating new visuals while utilizing different types of joins. So basically, I'll give you some data sets, and you're going to have to join those data sets in a certain way to be able to produce a specific visualization. And then the second one is on visualizing uncertainty, and we'll also have some stuff on tables and plot refinement there. Okay, we will have a lecture that talks about tables. People tend to not think about tables in terms of data visualization, because it's just numbers, but it is still a form of data visualization where you're taking data and you're putting it in a way for people to visualize what the data are, right? And so we will talk about tables as well, and I'll show you a few examples where it's pretty neat how, you know, in-depth and beautiful many of the tables can be. So quick note on reproducibility. There's this blog post here that you can check out where this guy Raphael basically goes through and finds a bunch of sort of popular media data visualizations and that have made their data publicly available, and he reproduces them using ggplot. So here's a quick example. This is for measles, but the rates of measles, and then when the vaccine was introduced and how that fell off from there. Okay, hopefully we see a similar sort of thing with COVID here soon. But this is what was published in the Wall Street Journal. They made their data publicly available. So he reproduced it and it looks like this. Okay, so it looks almost the same, right? Like even the color palette is quite similar. It's not exactly the same, of course, but it's very, very similar. So that's neat because not only does the plot look similar, but he provides the code to produce it. In fact, I think this isn't exactly what he produced. I think this is me using his code because it looks like it's a little jammed here on the side. So it got smushed a bit in the slide, I think. Okay, the other assignment, so this is the last assignment that you'll have besides the final project, is what I'm calling Data Viz in the Wild presentation, okay? So everyone, all of you, will, and I don't think people who are auditing the class are in this list, but if you want to be, please let me know. We'll see on the next slide. But everyone will have a 5-minute presentation on a couple of data visualizations that they found somewhere, okay? And basically what you're gonna do is you're gonna get at least 2 that are for 2 different audiences, ideally. Okay, so this one's for a scientific audience, and this one's for the general public, and this, or you know, if you're in education like me, this one's for teachers, this one's for parents, something like that. Okay, and then discuss what's trying to be communicated and how effective you judge that to be and why. And then for each of them, also say one area that you think is a strength of the data viz and one area for potential improvement. Okay. And then we can have a little discussion about them. And it's also just a way for us to all see a lot more data viz that's out there. Okay, so this is the presentation order. It was randomly assigned. You can actually see in the code for these slides, if you want, how I came up with this. Basically just put everybody's name, put a bunch of dates, and then randomly selected. So on the 11th, we'll have, oh shoot, so this is wrong already, because I have 3 presentations on the 11th and the 13th. That was supposed to be 2 presentations. So yes, because we have 2 presentations until the 3rd. So I'm gonna have to fix this. So I will email this out later, but it's basically gonna be something along these lines. So forget where your name is on here. And if you don't see your name on there and you want your name on there, please let me know. But it's going to basically look like this, where the order is just sort of randomly assigned, and you'll present for the first 5 minutes of class. Okay. All right. So yes, I will email this out right after class. Okay. Final project. Final thing we're going to talk about today. We have about 13 minutes. So it has 6 parts. Okay. The first is a proposal, which is just saying, this is what I want to do, and that's due on the 27th, okay? Then you'll have a full draft of what you're doing, and that doesn't mean it has to be published yet, and it doesn't mean it's perfect, but it means you have a draft of everything that you're doing, okay? That's not due until February 24th. It's due on the 24th because of peer review, okay? Peer review is another big part of the final project. You will be assigned 3 people to review. You're going to review you're going to fork their repos, review it, and submit pull requests. Then you'll do a presentation on either the 8th or the 10th, but you have to be ready by the 8th. And then the final product, which is due finals week. Okay, so the final product itself has 4 components. Okay, the first is it's a web deployed portfolio showcasing your data viz. Okay, so it can be anything basically. It just needs to be deployed to the web. In other words, it needs to have a shareable link that you just send me, right? So we'll talk about Distill. I'm going to lecture on Distill. And there's also our Markdown websites or Blogdown. So I'm going to lecture on Distill. There were recent updates to it that make it quite nice, I think. And it's sort of a good happy medium between our Markdown websites, which are very simple, but can still look really nice. And Blogdown, which is like pretty complicated, but you can do just about anything that you can imagine. All right. There's also technical documentation, which you can use with Pagedown or Bookdown. So if you're interested in either of those, I'd suggest you just look at these links. I'm not going to talk about either of those in this class, but they're really nice. I used Pagedown to create my Vita, for example. You could create a poster with Pagedown, like a scientific poster that you would present at a conference or something, or a Flex dashboard, which we saw a couple of those earlier. Okay. So that's one component of it. And then the other parts are you have to have at least 3 finalized data displays, as well as the history of each of those, and a strong narrative or story around them. Okay. So basically what I'm looking for is like, here's where I started out. This is what I was trying to do. And it kind of worked, but there was, this part was obscured or whatever. And then I did this, made this change, and it looked a little bit better, but I still wasn't totally satisfied with it. And then I changed the theme, and now I think it looks really nice, or whatever. I mean, that's really simple, but that's basically what I'm looking for. Here's where I started, here's how I progressed, and here's the final viz. And you need that for 3 different visualizations, okay? And then it needs to be housed on GitHub, be fully reproducible. So again, as I mentioned before, I'm going to just clone it and run your code, and it should just work on my computer just like it did on yours. If I need to do things like install new packages, that's not a big deal. I won't dock you points for that. But if I need to do basically anything outside of that, then you will start to lose points. Okay, so it should be fully reproducible. And it should be deployed through either GitHub Pages or Netlify. I'm going to talk about GitHub Pages because it's just so simple. But Netlify is what I use for the course website. It's what I use for anything more complicated. And it has some really nice features as well, like having deploy previews. So you submit a pull request, and then you get a preview of what that thing is, how that's going to change your website or your dashboard or whatever before you actually make it live. But again, I'm not really going to talk about that. If that's something that you're interested in, I'd be happy to meet with you individually to walk you through it. Okay. All right. So for the proposal, it also has 4 components. You see, I like to break things up into little steps. First, you're going to have a description of the data source, and the data must be publicly available. Okay. This is often a challenge because people want to work with their data that they're using for their research. If that's the case and you can't share your data publicly, then that's okay. We can work with it. What we'll want to do is we'll just basically create synthetic data from your real data, and then you'll use that for your actual final project. And then at the end, if you want, you can just swap out your real data for your synthetic data, and all of it should just run again anyway, and you just get updated plots and whatever. So the proposal needs a description of the data source, preliminary ideas for data viz. Also, I should mention, if you need help with creating that synthetic data, just let me know, and I will help you through that, because again, that's not something I'm lecturing on. All right, and then the identification of the intended audience for each viz. You should have at least, I think this is in the syllabus, but you should have at least 2 different audiences throughout your 3 data viz. So you could even have one plot that is shown 2 different ways for 2 different intended audiences, okay? And then the intended message to be communicated as well. Okay, and this is really not that big of a deal. I think it's worth 10 points or something like that. The main purpose of the proposal is for you to get feedback from me. So I can say, yep, that looks good, go ahead, or whoa, that seems way too big. You might want to try to dial back, maybe only use 3 of the variables or whatever, right? So I will just be trying to give you as much feedback as possible so that you can then, make those adjustments going forward, and you don't end up at the end and frustrated because things didn't work out. The draft, okay, so this is near the end of the term. I think it's week 8. It's expected to still be a work in progress, all right? So this is not expected to be your final viz. It's probably like your second or third iteration of that data viz, but it is not expected to be finalized. And in fact, it probably shouldn't be, because you're going to get feedback from your peers, and ideally you would incorporate that feedback into your final viz, right? With a lot of data visualization stuff, you can do things and it's like, oh, this is going to work really well, this is great, and then you show it to people and they're like, what in the hell is this? Like, I can't make heads or tails of it, right? So that's a big part of the peer review too, is like trying to get people to see what you're doing and if it makes any sense to them or not when they're coming into it cold, because you have lots of time invested into it, and you really understand the data, and your peers may not. And so if they don't understand it, then that's important feedback, right? It's not expected that it's deployed. It is expected that it's on GitHub, because your peers will need to clone it and submit feedback that way. But it's basically a draft that is in a form that is ready to share with your peers. Okay? All right. So peer review, I'm not going to hammer this too hard. We've never had problems with this in the past, but I just want to be really clear that this is a learning exercise for all of us. The purpose is for you to learn from the people who you're reviewing as you're trying to give feedback to them as well. So that's really all it's about. There's lots of different ways that you can take to get from point A to point B, right? And so by reviewing somebody else's code, you might see things that you hadn't thought about previously, and that'll help you be a more efficient coder going forward or whatever, right? So that's really what it's about. Just be kind, again, going back to the start, and there shouldn't be any inappropriate comments. And I'll review all the peer review also. We will be utilizing GitHub. You'll be assigned 3 proposals to review, and they're worth 5 points each. Okay, so 15 points total for peer review. What you're going to do is you're going to fork their repo, then you're going to clone it, then you're going to review it. Okay, so you can embed comments in their code. You can change their code. You can do whatever you want to do, because then you're going to push those to your remote, and then you're going to submit a pull request where they can compare the changes, and they can look at them and say, yep, this looks good, I'm going to merge it in, or no, I don't want to take all of this, so I'm just going to take bits and pieces myself and then move on, right? Presentation, the order will be randomly assigned. Again, it's basically just a chance for you to share what you created. I think this is probably my favorite class to teach, and in part it's because of what you all end up creating. It's super fun to see where you started and where you end up and the cool things that you do. So that's really what this is about. So just show your visualizations, talk about what's trying to be communicated, and then some sort of successes that you had along the way, things that you want to celebrate, those sort of things. Okay. All right, grading. Pretty straightforward. 200 points total. 3 labs at 10 points. 2 homeworks at 20 points. Data viz in the wild, that's 10 points, and then the final project is 120 points total, with that broken down across those different components. So 10 points for the proposal, 15 points for the draft, 25 points for peer review, which those things are switched. This is supposed to be 25 points, I think, and this is supposed to be 15 points. 10 points for the presentation, and then 60 points for the final product. Okay. There's the breakdown of the grading. And then communication, I mentioned this at the start, but as you're going along, you're almost certain to run into roadblocks. So please don't just keep hammering your head against the concrete wall until you break through, right? That's what I do a lot of the time, and it's not pleasant. I am here to help you, so please get in contact with me if you get stuck. And then just generally, if there's other things, anything that you want to check in with me about, things you aren't understanding, things that you want more information about, things that aren't necessarily related to the content of the class, but maybe the structure of the class or whatever, please just get in touch with me. We can have meetings. or we can just work through email, whatever. All right, so we are out of time today, which is what I expected. But on Wednesday, we will be talking about Git and GitHub. If you haven't, please do clone the repo after class today. And then if you have time, please review the reading before Wednesday on Git and GitHub. We're going to be using Git Kraken throughout, which I think is a really, really good tool for helping you use Git efficiently. Okay, so that's it for me with 1 minute to spare. It changed right as I looked. Any questions before we sign off for the day? I see a kitty cat. Okay, thank you all. I'm really looking forward to working with you all and doing some data viz stuff.